Okay. So integral. It's very hard for me to say. I don't know why, but anyway, I will put the R in the wrong place. So deal with it. All right. Okay, this is the integral of f of x.
You want me to do it?
I do it all the time. Integral of f of x dx equals, notice the big F. Okay? Big F is an antiderivative. Okay, what does that mean? That means if you take the derivative of big F, you will get little f. Okay, so it's the opposite of derivative. Okay, antiderivative, derivative, that makes sense. That would be opposite, right? Okay, so f of x equals x squared. What functions have f of x as a derivative? Come on, somebody's going to come up with the one, and then you'll go from there. How are we going to get, let me take,
Is it x cubed over 3?
it is, Emma, good job. Okay, it is one of them. Can somebody give me another one? Because if you take the derivative of this, you will get 1/3 times 3x squared, which is x squared. Okay, give me another one. Emma, don't give it to us. Come on, there's about 1,000 I could think of right now.
I mean, you can add numbers.
Okay, Molly, give me one. X cubed over 3. Okay. Now that she's given you that one, you could all give me a different one, right? Okay. The constant can be whatever, and it's still going to have the same derivative. Okay? So we're going to start with the most general antiderivative of f on I, as in on any interval that we usually talk about. F of x plus c, where c is that constant that Molly was talking about right there. Okay? And again, a function, big F, is called an antiderivative of little f on an interval I if f prime equals f of x, for all x in that same interval. Okay? So that's a definition. Let's try a couple. Okay? Find the most general antiderivative of each of the following functions. So this is, it's going to take you a minute to wrap your brain around this. This is weird. It's like, okay, this is the total opposite of what we've been doing for the last 9 weeks. Finding the antiderivative we'll call f, big F. Okay, so when we say this is the antiderivative, we could take the derivative and get sign. So what is it? Negative cosine of x. Okay, and if we want the most general, we have to add some constant c. Yes, we have to. And you'll see why when we do. We're going to call C, and then they're going to give you information to find the particular C. But yeah, you got to remember to find to put that C on, because that's important to find your most general antiderivative. You did your question?
Use FX or do you like this?
Well, you don't want to use little. You could do, you're going to change, and that's a good question. She said, let me make sure I understood you. She said, are we just going to call this big F? We are going to for now because of what we called it over here. We called it big F and little f. Sometimes they're going to switch this and they're going to say instead of this, they're going to call f prime, and then little f would be negative cosine of x plus c. So they're going to change up the name on it. Big F and little f is really kind of annoying, but it gets the ball rolling, and then eventually we'll switch it. But this is a pretty common, if you have f prime, get f, that's an antiderivative deal. Okay, they'll also call it the antiderivative. Okay, so what's big F over here, which is the antiderivative? When do we get ln of x? Good. Now, the most general is the absolute value. That's the most general because that is more general than just ln x. Okay? We never, rarely does that come up when we're doing antiderivatives, but now it's going to come up when we do antiderivatives. Because it's going to make a difference. So remember what we have to remember about this guy. X has to be greater than 0, so this is always going to ensure that, because absolute value is always less than 0 is always greater than 0. Okay? All right, what about this one? F of x equals x to the n. Go ahead. Nice, Abby. Okay, little big F here. You pull that around, and then you divide it out, and you subtract that. Okay? All right, very good. Okay, so those are 3. We're going to do a few more over here, but I kind of compare antiderivatives to subtraction. Remember when you were little, I know it's been so long ago, and you practiced your addition facts? And then they just assumed you knew your subtraction facts because you knew your addition facts, you just have to turn them around. That's the thing with the antiderivative. You know your derivatives, then you can figure out the antiderivative. You don't know your derivatives, you're not going to recognize, oh wait, that's a derivative of, so that's what we're going to do. We'll make a partial list, but it's not like you just have to figure them out. And we're going to go through and do some techniques of finding antiderivatives already. Also, find a function given its derivative. Okay, here's the derivative. G prime of x equals, that looks pretty complex, but we're going to change its form so that it's this minus this and this. Okay, and we'll simplify to that 5x to the minus 6 minus 4x to the what? -3 and plus 2. Okay. Now, if this is your f prime, you should be able to apply that to that rule for each individual thing. So we'll call it, I guess since this was g prime, we should call this g of x. All right? Instead of big F and little f. They're going to switch that up on you, and just be very, very careful. All right, so we're going to use this rule. The 5, remember, just shows up. We save it, it's the same thing. Okay, if we're going to use Abby's rule here, we're going to take the -6, we're going to add 1 to it. We're going to divide by that same number. I already did that in my head. Okay, all right. For anyone, right here. I can do that in my head, yep. Well, because I wanted to show that what are we doing. Okay, what does that simplify to be? Just the one piece. -1 x to the -5. Okay, now, check the derivative on this. Y'all can do that in your head. Pull around 5, you have -1 times -5, that's 5x to the -6. That's what we had from the beginning, right? Okay, so g of x equals -1 x to the -5. All right, we got 2 more terms. Don't say them out loud. Just do them and then we'll regroup here. Check your derivatives, make sure that they are this when you're done. Before I check the 1. Have you get your plan or someone else? Okay, ready? You found, what'd you get for your second term of your derivative, of your antiderivative?
Positive 2x
2x to the what?
-2.
Okay. So again, I'm going to check her out. I'm going to multiply -2. I'm going to take the derivative of this, and I'm going to get -4 x to the -3, which is good. Okay? And Allie Creed, what'd you get for the last term?
0. Or no.
I'm asking you first. Is the derivative of 0 2? Oh, 2x. Okay. The derivative of 2x is definitely 2. And see how it's you're gonna mess with it because you're gonna put derivative down here because that's what you're used to doing. You just gotta double check until you get used to the process. Double check the derivative of that is that. The derivative of that is that. The derivative of that is that. We're good. And don't forget the see, how many of y'all remember that? Good job. All right. There's your g of x. What is this all about? Why is that there? It says the domain is from -infinity to 0 and 0 to infinity. Why did I have to talk about that? There's a denominator that x cannot be 0. Okay. You don't have to really worry about that. That still exists for, you know, this too. Is this. Okay. All right. Any questions about that? All right. Let's look at this chart here and kind of just work on some of these general antiderivatives. Okay. We're going to talk about this one, n plus x to the n plus 1 over n plus 1. All right. Please note, n is not -1. So this, remember, which is this. Oh, wow, that's right there. So that's an exception to that rule because we've already talked about what the antiderivative of this is, right? What is it? ln absolute value of x. Very good. Now, I'm putting my plus c on there. Okay. So you're going to make that mistake. You're going to just get used to that power rule. The antiderivative power rule is this thing right here. You're going to get used to that, and you're going to get x to the 0. Okay. That's a hint that, oh wait, there's a different one that we need to know. Okay, what's the antiderivative of e to the x? E to the x plus c, because derivative of e to the x is e to the x, derivative of c is 0. Okay, very good. Derivative of antiderivative, sorry, cosine of x. Sine of x plus c. Derivative of sine of x is cosine. Derivative of c is 0. Okay. Sine, I think we've already done. Negative cosine of x plus your c. Derivative cosine is negative sign. To make it a positive sign, we do the negative. Okay, keep in mind that negative thing is going to be an issue. Just remember your co-derivatives are negative. So I wouldn't try to remember, oh, this one's negative. I'll just say, okay, I'm going to take the derivative of this. It's going to be negative and take care of the negative sign. Just double check yourself. Okay, what function has a derivative of secant squared? Tangents. Very good. Okay, and that's what I mean by, wait, if you didn't recognize that one as a common derivative, then you're not going to be able to find it. There's not any techniques. It just has to be your rule. What function has a derivative of secant tangent? Secant. Very good. So there's all those you got to really remember back and forth. Remember that one? Inverse sine. Very good. Okay. Could it also be somehow be inverse cosine? It could be negative inverse cosine. It'll work out the same way because this is negative, and then that would take it back to a positive. Okay. What about this one? 1 over 1 plus x squared. Which one is that? Tangent, inverse tangent, or inverse negative inverse cotangent. Negative inverse cotangent. Okay. Which one has a derivative cosecant cotangent? Negative cosecant. X, yes. Okay. Cosecant has a negative, so in order to have a positive here, that negative cancels itself out. And then what about cosecant squared? Again, cotangent, yes. Okay. So those are just some of them that are going to come up. You want to make sure you're not forgetting about your derivatives because you're double checking them. You won't get them wrong if you double check them. You'll get them wrong if you don't remember them, but that's problematic anytime, right? Okay. So anyway, we're going to switch up the terminology a little bit. Instead of calling it a antiderivative, it's the same thing in a little bit way. I'll explain here in a minute. But it's called an indefinite integral. Remember, this is an integral sign. It's supposed to look like an S because it's a sum. Eventually, you're going to relate it to, how is it related to those Riemann sums and those trapezoid sums? It's definitely related there. Okay, but that's where that thing is. That's a summation sign. Kind of evolved here into here. It's supposed to look like an S. Okay. All right. So the integral of f of x d of x is used for an antiderivative of x and is also called an indefinite integral. We also have definite integrals. Okay. And same idea. This integral equals f of x means when we take the derivative of this, we have this so much. Okay. So they're going to say it like this. The integral of 10x to the fourth minus 2 secant squared x dx equals, you are looking for the antiderivative. Okay? They're not going to use both of the languages typically. Okay? All right, so go ahead and do that one.
It's we're finding the antiderivative.
Yes, ma'am.
So you just draw that on the sign and say that equals it?
Yes. We don't draw this again. It's sort of like taking a derivative. Once you say that and there's no, this sign isn't there. Is that what you asked me?
But like, if I usually would write like f prime of x equals, I write that equals.
Yes, yes. Ugh. Let's try this again. All right, everybody ready? Okay, what's the first term of the antiderivative, Miss Allen Rivers? 2x to the fifth. 10x to the fourth, yes, it's the derivative. Very good. All right, Lindsay, what's the second term? Is it plus or minus? Minus 2 tangent x. The derivative of tangent and secant, the 2 is a constant. Very good. And what's the third term? Emma. C. Okay, so that is the general antiderivative, and yes, you need to include that C. Okay, so double check them. You should be good. One, I'm going to try and left you so much space. Usually that's not a problem I have. Okay, so that is finding the indefinite integral, which is the antiderivative. Oops. What do you got, Sarah?
I have x to the fourth over 4, and then I have minus 3x plus c.
Okay, very good. Okay. You can check it out easily enough. Y'all are good at that. That's your indefinite integral. It's also your antiderivative. So, all right. Now, here's where, what? This is how we kind of see. That's right. Okay. And this is more typical language, like I explained, that big F is going to go away. It's usually going to deal with F prime and F instead. It's just a lot more manageable. But anyway, you will still see big F occasionally sometimes. All right, which is redundant. I get that. Okay, so here's your F of X. All right. So let's find F. Okay, so F of X is the antiderivative of F prime of X. Dx is that. Just tells you, just FYI, I haven't mentioned this yet, that dx is symbolic of the derivative. So this tells you, oh yeah, that's the derivative, even if it doesn't look, this is clearly a derivative, but this is also tells you it's a derivative inside it. So we want the antiderivative. All right, first piece is easy. Okay. Now that other is a little bit tricky. You gotta manipulate a little bit so you recognize it probably. I'll walk around and see what's got going on here. Nice. I don't think it works. Double check your derivative. It's a good idea, but there you go. Don't lose your 20. Oh, wait. No, the 20 doesn't go anywhere. 20 is just a constant. All right. Remember that with this, right? Which is really this.
Minus 1 over 1 plus x squared.
Okay. That one you should recognize as a common derivative. That's all we're doing right now.
Which one do you choose?
I'm just saying one. Oh, I get you. You could do either one. Probably the simplest.
Okay, that's
Do you
fine.
know,
How do you know what?
how do you know what this is?
Say that again.
Never mind. It's
Okay.
going to negative.
Okay. Got it? Aaron, what'd you get? Inverse tangents. Anything else? All right. Let me get this over here. Let's see. Okay. Now, Ella asked, you know, we talked about when we did our chart, could be an inverse cotangent if you want to do the negative piece. The positive piece is simpler. Let's do the simpler. It won't matter in the long run which one you do. Okay. Plus, wouldn't we rather do inverse tangent than inverse cotangent? I think it's more common. Okay, so this is f of x, just to be clear, is this. Okay? Now, we also know f of 0 equals -2. So here's where we're going to find our specific c. Now, imagine our trouble if we hadn't put our c in, and then we're like, oh, we're done, e to the x plus 20 inverse tangent x. Okay, so it's really problematic if you don't get in the habit of doing your c. Okay, what should we do with this? F of 0 equals -2. Any suggestions?
Plug in 0 for x.
Plug in 0 for x, and what? Okay, so f of 0 equals e to the 0 plus 20 inverse tangent of 0 plus c equals f of 0 equals -2. So basically, you're going to solve that equation. Right? Any questions about that? E to the 0 is what? Plus, what's inverse tangent of 0? 0 plus c equals -2. This is 0. 1 plus c equals -2. C equals, okay, so really, what's f of x?
15 and x plus 22. We're saying x minus 30.
Very good. Okay. Yes, the derivative, and again, you should be able to check out your derivative. Make sure that that derivative is what we started with right here. And that f of 0, when you plug in 0, you in fact do get -2. Okay, so they're all checkable. And please do that. Please check your derivatives until you're used to the process. And then you won't make silly mistakes. Okay, let's try another one. Now we're starting with f double prime. Okay, so we're going to work backwards to f. All right, so if I take the integral of f double prime, what does that give me? dt, which would be the right language. What would that give me? Just generically. F prime, good. Okay, and then I'm going to take the f prime integral, and then I will finally get f of t. So you're going to work backwards twice. All right, we'll save this here for when we're ready for it. All right, let's put in 3 radical t dt. That's just language. Just get in the habit of these two. The letters should match in there. And the d stands for the derivative sitting there waiting for you. Okay, we're looking for an antiderivative. All right. Go ahead and do that. I'm going to switch up my language here a little bit. Residual power, maybe. You don't have very many techniques right now here, people, so you got to get it to a recognizable form. Right? You would have done that if you were going to do a derivative as well. Now, what number has that? See. That looks good. All right, that looks good over each C. Okay, so I have seen 6t to the 1/2. 6 times 1/2 is 3. 1/2 minus 1 is. Okay, don't forget your C. All right, so that's f prime. Okay, it is, if some of you all are going to really be really messed with this because you have to change everything you thought you knew, but that is what it is. All right, so you got to get used to it because it's the second part of, because this is the second part of Calc 2. So I'm going to fill in my 6t to the 1/2 plus c. Okay, now that's going to be a little awkward. Do I know anything about finding c before I do that?
Oh, yeah.
Okay, so let's do, before I do this, let's find c here. You know f prime is 6t to the 1/2 plus c. We know f prime of 4 equals 7. Okay, so let's find c. F prime of 4 means we're going to put 4 in for t. And that is going to equal 7. All right. What's 6 times 4 to the 1/2? What's 4 to the 1/2? Square root of 4, which is 2, right? So 6 times 2 plus c equals 7. 12 plus c equals 7. C equals what? -5. Okay. So we should plug in a C right here. Okay. That would be easier than dealing with the CT, which we could do that, but okay. Now go ahead and find f of t. Do we know anything? F of 4. We're using that 1/2, that +1, and divide by that same number. And you'll get a system when you figure it out. Okay, so f of t, did we get 4t to the 3/2 plus c? All right.
Minus the 5. Minus 5.
Duh. I can see that face. Okay. All right. Are y'all getting that antiderivative piece?
Yeah.
Everybody? Okay. And then you're gonna put this piece, this information together here. And f of 4 says to put 4 in. 4 to the 3/2 minus 5 times 4 plus c equals 20. Okay. Remember, this is the square root of 4, and then to the that power. So that's an 8. Do that usually in that order, as opposed to cubing 4 and then trying to find the square root of that is a lot more work. Okay, minus 20 plus c equals 20. So that's 32. 32 minus 20 is what? 12 plus c equals 20. C equals 8. So finally, f of t is what? Molly?
Minus 5t.
Okay. Again, if you want to double check here, we pull that around, we get 12 t, let's see, no, we get 6 t to the 1/2 minus 5, which was f prime. We pull that around and we 3 t to the negative 1/2. Everything else should fall into place. Okay? All right. Any questions? Sometimes it takes a little bit longer. It gets really kind of makes you crazy, kind of confusing. Just hang with it. Make sure you double check you are doing the +1. All right. So this is the last page we have to do today. Antiderivative differentiation is, we're going to be using it in with respect to position, function, velocity, acceleration. We did that in 3.8, except we were working with position function, and then what's the derivative of position function? Velocity, and then the derivative of velocity was, okay, so now we're going to go backwards. All right, so position function would be the antiderivative of what function? Velocity. Okay? So use the names, use your names. V of t, position usually is s or x of t sometimes. Okay? The velocity function would be the antiderivative of the acceleration function. Okay? All right. Just FYI, I have been very careful about identifying what you know, what we're going to get when we take the antiderivative, what we're going to get when we take another antiderivative. Keep that. It'll help you organized as well. So let's try this. It's very similar to what we just did. The particle moves in a straight line and has acceleration given by a of t equals 6t plus 4. Its initial velocity, v of 0 is -6, moving backwards, and its initial displacement is s of 0. Okay, displacement is a distance. Okay, and find its position function s of t. Okay, so where are we going to start? Where are we going to start? Come in a language. Antiderivative acceleration is going to give us what, Molly? Velocity. So let's write that out. Okay. Which is 6t plus 4 dt. All right. Antiderivative. Cindy. Okay.
Plus 3t squared plus 4t.
3t squared plus 4t plus c. 6t, 4, yes. Good job. That's the antiderivative. All right, now what should we do, Sarah?
We should set, we should do the v of 0 equals -6 centimeters
Okay,
per second
so that means put in
and 0 for
t. Good. And that gives us -6. 0, 0, c equals -6. So I'll give you what's v of t.
3t squared.
All right, good. Okay, we're just going to circle that. Okay, now we are looking for s of t. Abby, what do we want to do now to find s of t? Very good. 3t squared plus 4t minus 6 dt. All right. And you finish. You get
2 cubed plus 3t squared 16 plus c.
Okay, very easy to check. 3t squared, 4t minus 60. Nice. That's your s of t, almost. We also know that s of 0 is 9. So we're going to put in 0, well, and c is going to equal 9. So finally, the s of t equals what you face said plus 9. Okay? Again, it would be very easy to work up backwards to check that out. Okay? Don't assume you don't have to do that. Okay? Because that's how you would check. You'll find some goofy errors. So that's all we're going to do today. 5.3 is next, and we're going to try and tie in the Riemann sums with the integral and see how they're related. But we're not going to do that today. Okay.